right, welcome back from Easter break. Here we go. We're diving into atmosphere, temperature, and oceans. Oceans are super fun. We really stay in oceans for a long time because we're going to go into oceans when we get into ecology. We're going to go into oceans about some animals. It's really fun. We love oceans. So let's dive into this. Here's your basics today. It's a science kickoff. It's a 5 through 8. Hopefully you figured that out. In case you are watching this before Zoom, now you know it's a 5, 6, 7, 8 today. Science week. So the slideshow is in science. Let's keep this basic because it's a Monday and time goes fast. So first thing, move temperature, climate, energy to top and add visual support. Follow my lesson, which you're watching right now, through lesson number 1. Top slide, research this question. What is the climate of Los Angeles? So you're going to create a top slide and just say, what is the climate of Los Angeles? All right, let's go look at our slideshow. Got a video to watch. A lot of this stuff we'll browse through. You can read it in details later. Today we will begin a new unit called Ocean, Atmosphere, and Climate. Read the unit question on the next slide. This is the question that will guide our work for the rest of the unit. Unit question, what determines the air temperature of a location on Earth? You can probably think of a place on Earth that is usually very warm or a place that is usually very cold. Have you ever thought about what determines the air temperature of a place? This is what we will focus on in the Ocean, Atmosphere, and Climate unit. Exciting. Let's watch a video about real-life scientists who are researching air temperatures in different places and what it is that can make the air temperature change. Of course, the videos are available in your home units if you research it up. All right, let's check this out. Here we go.
I'm Marty Hurling. I'm a climate scientist at the National Oceanic and Atmospheric Administration in Boulder, Colorado, and I study El Nino. El Nino has some puzzling aspects to it. It lasts 6-12 months. It returns maybe every 2 to 7 years. When El Nino happens, the ocean temperatures change and the air temperatures change over the whole planet. And they can change by, almost 0.2 degrees Celsius, almost a ½ degree Fahrenheit. And that kind of change, you might say, well, that's not very big, but actually it is big, and we can see it happening. El Nino is something that causes radical changes. Some places get way too much rain and they get flooded out, and it can be damages to homes. Some areas that normally get rain, suddenly the rain shut down. They get fires, drought, their crops don't grow, a lot of problems. We had this big El Nino this past year. It was so big that we decided within NOAA to go out and hunt it down, take new measurements to see how it ticked. We combine planes, ships, we go to remote islands, we launch balloons.
My name is Dan Wolf. I'm a research meteorologist, and I was part of the El Nino Rapid Response Project. The ship traveled from Hawaii to the equator, collecting ocean temperature and also releasing weather balloons as we went. The data are transmitted real-time back to a computer on the ship where we can watch it. Then we can send it back to Boulder where modelers use it to help better understand the weather and El Nino.
I'm Dr. Leslie Harton. I'm a research meteorologist, and this spring I spent 5 weeks on a small island called Christmas Island in the equatorial Pacific. And we went there to launch weather balloons. Christmas Island is in a part of the world where there are almost no regular weather observations. And it's also right at the heart of the El Nino that was happening this year. We launched our weather balloons at 1:15 in the morning and 1:15 in the afternoon. An instrument package like this is attached to the weather balloon. And as the balloon goes up, we measure temperature and humidity and winds and pressure. Our data give us a really unique picture of how the atmosphere is behaving in that region when there is a strong El Nino.
Hey, Honolulu, this is Boulder, and we're ready to go through the briefing this morning. So every day, the aircraft would have to fly out from Hawaii to the equator to get some idea of what El Nino was doing. Kelly, do you expect both radars on board to be active to help you through that convection?
Yeah, thanks, Marty. We should have both radars working on today's flight, so that will be a big help.
I'm Dr. Kelly Mahoney, and I served as a mission scientist for the El Nino Rapid Response Project aboard the NOAA research aircraft. We had manned aircraft with the whole flight crew aboard it, and then an unmanned aircraft. And the mission of both of these aircrafts was to go out and get close enough to thunderstorms that we could either circle around them or get close enough to feel some of the winds that were coming out of them. As we got close to the thunderstorms, our job was to drop instrument packets out of the airplane to measure the temperature, moisture, and wind speeds right around the thunderstorms. The data that we collected is truly unique and very useful and valuable to our weather and climate models.
So I really like doing this science because we're trying to understand the way El Nino works, the ocean and the atmosphere, how they link. It affects weather patterns. Many people's lives are really affected by this. And that's really why the data are so important. It helps us make better forecasts and helps people's lives.
That's pretty cool. That is pretty interesting. Think about all those different jobs. You have to have a pilot. You have to have a scientist. Somebody has to design, some engineers to design the little weather machines. That's pretty fascinating. All right, let's keep going here. What are your reactions to the video? Do you have any questions about it? Let's take a little break now. Do you remember anything about El Nino? Were you guys even born then? I don't know if you were, because we did have an El Nino in LA. What do you know about climate? How could you describe it? What do you think the Los Angeles climate is in general? Not like just today, but in general, how would you describe Los Angeles climate? We'll do a little release the Kraken on that. Just be thinking about climate versus weather. Okay, if you're in Zoom with us, we'll do that now. Back, good responses there. Yeah, it's generally warm here, people say. Not very cold. Seems to be dry, but not super dry like a desert. People talked about some trees and, of course, the ocean. So, yeah, our climate, I'm not going to give you the answer, but there's types of climate that I want you to make as a top slide. That's part of our assignment today is what is Los Angeles climate. And there's a name for it, but I'll let you figure that out. All right, let's keep going. There it is. There's our word climate. General weather patterns over a long period of time. Throughout the year, you can look up vocabulary. We know about that. Climate scientists or climatologists study weather patterns over a time. For example, a location's average temperature over a long time, not the temperature on one particular day. On the next slide, you will read a message from Kiri Parada, the director of New Zealand Farm Council, to learn more about what you will be doing in this unit. All right, here's our mission. Very important because it always carries through, probably for a couple of weeks. I am the director of New Zealand Farm Council. Our organization represents farmers in the area surrounding Christchurch. Notice a little tie into our history. Why would a city be called Christchurch in New Zealand? Well, we just studied ancient Christianity, the spread of ancient Christianity, and ancient Christianity spread so far around the globe that someplace this far away, you'll see it in a minute on a map, actually named cities after it. Our organization represents farmers in the area surrounding Christchurch. Every few years, we notice climate changes that affect crops. During El Nino years, the air temperature is much cooler than usual, and we would like to learn why. So the farmers are better prepared for these temperature changes. We are asking you, our student climatologists, to conduct some research on what determines Christchurch air temperature, especially why it decreases during El Nino. We're going to help the farmers. I like it. Looking forward to working with you. Thanks, Kiri. We'll talk to you soon. Climatologists expect particular locations' climate to stay mostly the same. When they get data outside of the expected pattern, it often leads them to investigate the cause of the unusual data. In this unit, you will work as student climatologists to investigate why Christchurch, New Zealand's air temperature is cooler than usual during El Nino years. Like the scientists you saw in the video, you will work with real climate data to conduct research about El Nino. This is similar in many ways to the work done by professional scientists. So we're going to look for climate data. Cool. Now examine the map below. You're going to see that New Zealand is a country located in the southwestern Pacific near Australia. There are two main islands that make up this country. New Zealand, Christchurch is on the South Island. There's a yellow star on the map to show us. So let's take a look at the map. Now check this out. Here's the United States. We're going to study ancient civilizations or cultures down through South America, Central America next week when we go into history, and we'll look at Mr. Downs' virtual field trip. So that'll be next week. Over here's Africa. If you look up here, they kind of cut us off here. Here's Africa, and I don't see the other side because this is Arabia. India and China we're going to dive into in a couple of weeks. But so look where we are compared. Christianity's spread was way over here. Remember in Jerusalem? And then it came up into Rome. There's Italy. I think that is Italy there. And so it came up into Italy, the Roman Empire, which controlled all this. At the time of the Roman Empire, nobody knew what was going on over here. Had no clue. Nobody knew about any of this stuff. There's Australia, that we know of, they were not coming here. Maybe some people coming over into the Americas, but way down here, no. So by the time of this lesson, common time, somehow Christianity made it all the way to these islands. So kind of fascinating. Look what we can learn from visual support. This is basically a slideshow like we do that they use to teach us and we use to teach each other. So here's our question. During El Nino years, why is Christchurch, New Zealand's air temperature cooler? Well, we got to figure that out. Why does it get cooler? Climatologists use the term atmosphere to describe the mixture of gases or air that surround a planet. We'll be investigating the air right above the surface, not the air high up in the atmosphere. So air that we can actually deal with. When we talk about the air temperature, we are talking about the temperature of the air directly above Christchurch. During El Nino years, why is Christchurch, New Zealand's air temperature cooler than usual? Well, here are 3 claims. So we're going to think about these 3 claims tomorrow when we start playing with a sim and we start investigating things. We don't have to make these claims yet. We're just thinking about them. The amount of incoming energy from the sun changes. Could that be changing things, making the air temperature cooler? Maybe the sun gets cooler. Something about the Earth's surface, which is land or water, changes. Or something about the air changes. Interesting. Now, we're going to use a simulation, but we're going to dive into that tomorrow because we're going to run out of time. So we'll look at this simulation video, or I will play with it in a video for you tomorrow so we can see the question, what determines the air temperature of Christchurch, New Zealand? And we know that to understand why, we'll need to figure out causes of a temperature change. Now, we'll get into all that tomorrow. Right now, let's dive down here, and I want you to just move the energy and the temperature slide. Move the energy and the temperature slide to the top. We'll jump into this lesson here tomorrow and play with the sim, and then go find the climate slide, move it to the top. So you'll have climate, temperature, and energy at the top of your slideshow. Add visuals, understand the concept, look at the picture, read what it says, general weather patterns over a long period of time. Try to understand vocabulary. When you understand and have a good vocabulary, boy, your knowledge increases like you wouldn't believe. It's all about knowing what things mean. So take time to understand the word, understand what it means right now, and then create a top slide. What is the climate of Los Angeles? So you basically have 4 slides right now. Basics, no CRs. You don't even have to write on this one. What is the climate of Los Angeles? You can write down some of the answers we said today in your own words, or just go get the answer from the internet. So you can do this pretty quickly. Temperature, climate, what was the other one we had? Temperature, climate, and energy. And then what is the climate of Los Angeles? All right here. If you're in Zoom, you've already watched the video. Have a great day. Let's do this. It's a short day Monday. We're probably running out of time. We're back. Science Week. Have a good day, everybody.